Okay, I'm going to do another code refactoring. Again, this is some student code, and again, it is perfectly reasonable code, but I want to show some ways that we can maybe make it a little simpler, easier to understand, easier to modify. So this, as you can probably tell, is the start of a Tic Tac Toe program, and basically what we've got here, I believe, is the code to draw the board, the lines of the board, and then an on-click function that's going to draw the X's and the O's. So this is basically dealing with the graphical parts. As you can see, there's a bunch of code to handle the clicks, and that's the code I'm going to focus on. So first, let's run this and see how it goes. So kind of working, not really putting the letters in the right place. That's not actually my main concern, but I bet by the time we're done, that will also be sorted out. So the first thing I notice that immediately leaps out to me is there's a lot of duplicated code at sort of all levels. For one thing, if we look at this whole chunk of code that draws the X's and this whole chunk of code that draws the O's, I haven't examined every character, but it looks like they're pretty much the same except for one draws the X's and one draws the O's. So maybe the very, I can sort of, logically they have to be the same, right? Because the logic doesn't matter which character you're drawing. And a quick perusal here is like X is less than a third of the width and less than a third of the height. We draw it in 7540. I guess the color is also different, red and blue. So we've got two things. We've got the letter and we've got the color. So maybe the very first thing I would do is make variables, which I don't even need to, I need to declare the variables, but I don't need to give them a value yet, because then I'm going to set it. I'll just copy this if, and so if we're on an even move, it's X's turn, so that means the marker is going to be X, and the color will be red. Otherwise, so now this is basically the equivalent of this whole chunk, we'll just set the marker to O and the color to blue. And so then that means if I'm right that those are the only differences between these two big if-else blocks, then I can now get rid of this condition. Actually, I could be even more careful than that. Let's see, there's probably a find replace, change all occurrences of, does that work? Maybe it doesn't. Okay, that's annoying. Replace X with marker. Let's skip that one. I don't want to replace that. Okay, so now I've replaced all the X's with marker. I'm going to replace all the O's except for the very first one with marker. So that looks good. And then I'm going to find and replace red with color. Not that one. Blue with color. Okay, so now I can check even more carefully. These lines should all be the same. I'm pretty convinced they are. Okay, so that means we can delete this if and this whole else, because those, the if and the else branch are now equivalent. Reformat. And we've almost halved the amount of code. Okay, the next thing I notice is that this all of these conditions, I bet there's 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, which makes sense because there's 9 squares on the tic-tac-toe board. So this is doing it as like 9 separate things, combining the x and the y. But if we look, we can see there's a bunch that check x is width of 3. The editor even highlights it for us. It misses this one because it was written slightly differently. But if we change this to be written the same way and highlight this, we can see there's 3 of those. And then they each have a different y condition. So that suggests to me that maybe I can combine all 3 of those. So if the x is less than the third of the width, then I'm going to do that. So far that hasn't changed anything. I just sort of broke apart the and. But now I can take the other branches where we check for the x being in the first third and just take the y part of it, and what we do, I'm going to go ahead and cut that and say else if let's see, and then that should be indented, and the one I just deleted I can get rid of, and then I can look for the third one and do the same maneuver. So I'm just combining things into logically equivalent chunks, put a closing brace, go back here and delete this. All right, oops, I got an extra brace in here somewhere. Or missing brace. No, what do I have? Extra parenthesis. What's going on here? I don't know where that, oh, the extra paren came from the, all right, this is why formatting helps us out. Okay, now everything looks right. So we've got the one branch for all of the things that are in the first column, where x is less than a third of the width. And then we have a series of where x is greater than a third and less than 2/3 of the width, so basically in the middle column. And I'm going to just make these the same as it's written down here. And so now we should be able to find those. One more that's written a little differently. Okay. So greater than a third and less than 2/3. I guess I'll go ahead and leave that as it is. So, but the same idea. So for all the ones in the middle column, we're going to handle them all in the same if clause, and then make a nested if to handle the y part of it. So that goes there. The next one where we're looking for greater than a third, then we take the y part and what it actually does, combine those, else if that, closing brace, delete that, and then the last one here, and delete that, and this should format properly. Okay, so now we've got one first branch of the outer, second branch, and now we just need to combine all the third branches, which are all the ones where it's greater than 2/3, i.e. in the last column. And so same trick as before, make it its own case, and then these are all going to be together, so we can actually just join them up and delete the part that deals with the x because we've already checked that. And again, the part that deals with the x. All right, so now we have And we need one last closing brace. So now we have, instead of 9 separate conditions checked, we have 3 times 3. So it still comes out to 9, but we only check each of the x things once. So if x is less than this, if x is between that, and x is greater than that. So then the next thing I notice, okay, so let's actually run this and see what happens. Syntax error, missing paren after argument less line 40. What happened? Oh, what? Oh, I somehow, too many braces. Should have noticed that when I formatted. All right, I bet that works. Okay. Positioning is a little bit off. Oh, and I should say, I bet the reason this positioning is off, we'll get to this in a little bit, but I'm running this on a different size screen probably than the student had at school. And so some of these numeric values, 75, 280, and 490, whatnot, maybe work on their screen, but not on my screen. So we'll get to how to make that a little more robust in a second. So I imagine that this looked right on the student's computer. Okay, so this didn't make the code a ton smaller because we still have ultimately 9 calls to draw a text marker, but we've organized it. It's a little easier to see that there's like first figure out the column, then within each column figure out the height. Now if we further clean these up, we'll see we have a very similar kind of duplication where the first if inside each of the outer ifs branches, first we check whether height is less than a third, and then we check whether it's between 2/3, like greater than a third and less than 2/3, I think, and then finally they're like greater than 2/3. So it's checking the rows, the first row, second row, third row, and then for this middle column, first row, second row, third row, and so forth. So that is also duplication, and so we have to look at what differs between the duplicated code. Obviously, so the conditions are the same, but the thing that differs is what, I guess, what makes sense is what x position we're drawing the letter at. If we're in the first column, the x position is 75. If we're in the middle column, it's 280. If it's in the last column, it's 490. So that suggests we can do a similar thing as we did at the very beginning, where we can make a new variable, and we'll call it xpos, and I'll just leave it up there. And then we could say, let's copy all of this. Just temporarily, so we have keep a clean copy of it. And then we'll basically just say, okay, if we're in the first column, xpos equals, what was it, 75. If we're in the second column, xpos equals, look down here, it's 280. And if we're in the third column, xpos equals 490. And so now, similar to before, we can take any one of these 3 and we'll just change this one to use xpos. And we can just realize that if we change the other 2 sets to xpos, then the blocks inside each branch would be the same, which means we can get rid of all of this. Reformat. And so now we have figure out the move, the marker and the color, figure out the xpos based on the graphical x coordinate. And now you might feel like, oh, we're pretty done. But we do actually still have the duplication of there's 3 different calls to draw text, which differ only in the argument passed in the y position. So that suggests we can do exactly the same thing. Oops. Copy that, and let's go ahead and change that to y position, create a new y position variable, and then do the same thing in here where y pos equals 40, y pos equals 90, and y pos equals 140. Okay, and then after having set those two variables, we have one call to draw text. And that kind of makes sense just if you think about it, like every time we click, we're going to draw one thing. So it kind of makes sense that there's only one call to draw a thing. Excuse me. And the only difference is we just have to figure out, the marker, the positions, and the color. And then this last argument is the font size. So that's fine. Okay, so that's pretty good. And let's give it a shot. All right. So I think I'm going to go ahead and try and fix this so it works on my screen. And it's going to be a lot easier to fix now because the numbers are only in one place. Before we had like 3 places where 75 was and 3 places where 280 and all these. But now we know, okay, we figured out the position in the x position in the first column. Maybe it shouldn't be 75. We can think about what should it really be. And the first thing that I would think is like, well, the board is covering the whole width. And so the letters are going to be each like some relation to the third of the width. So what if we just said, if we set the x position to be width divided by 3? And I'm pretty sure that's wrong for reasons we'll see. But it's kind of close. And let's just try it with just the one. So if we click in this first column, it should put, okay. Well, it looks like the position of the text starts at like the left side of the text. So it drew it right on that line, which is at 1/3 of the width. So alternatively, we could say the x position is 0. And now we click in the first column. Yeah, so that puts the x sort of at 0. But what we really want is we want it kind of centered. And this is a little harder because we don't know exactly how big this font is. I mean, it's some function of the other things. But we can kind of eyeball it and say, this x looks like there'd be like 3 of them that would fit in there. So maybe this is, if we added a 1/9 of the total width, or a 1/3 of the width of one column, then, and let's do it this way, 0 plus, we'll just call it width over 9. Okay, so that is in the x-axis positioned correctly. And the y is maybe a little off. It's down, we drew it at 40. Remember 0, 0 is at the top. So 40 down, I guess that I could believe that's 40 pixels. But we want it more down here. And again, it's kind of a function of how big this font is. Let's go with, it's kind of like we did before. Let's just try height divided by 3 and see what that does. Okay, so that puts it right on the line, but that's too much. This time, and now I'm just eyeballing it, I would say maybe height minus 3 divided by, or sorry, and then subtract a little bit to move it up, but I don't want to put in some actual number because if my screen size changes, then it won't work right. So let's say we shift, oh, maybe it would be kind of another 1/3. So maybe similar to before, what we did with the x, I'm going to subtract height divided by 9. So a 1/9 of the total width, or a 1/3 of the sort of one row. That's a little bit too much. I don't know, but let's leave that for a second and say, okay, that's kind of right. The other rows are still going to be hardwired. So now we can think about, well, what's the equivalent? Let's go back to the x. So we got the first column working right, but the second column is hardwired to 280. Sorry, not 1. So this 0 is 0 because it's in the sort of the 0th column. If we wanted to be here in the same relative position in the second column, we need to start at this line, which we actually saw before is height divided by 3. So we can say height divided by 3, or sorry, width divided by 3, because that's the first line, plus width divided by 9. Can't type. All right, run that. Okay, that's positioned correctly in the column. And then we can see that this line is 2 times width divided by 3. And now we can kind of see the pattern. So this one is 0. We can also think of that as 0 times width divided by 3. That's a little silly. But this one is 1 times width divided by 3. And this is 2 times width divided by 3. And again, plus the width 9 to get it centered within the box. So now things get centered properly in the columns, and we need to do a similar thing here. So for the y, we did height divided by 3 moved us down to this line, and then we backed off a little bit, maybe a little bit too much. So that suggests that to get in the right position in the middle row, we want to go to 2 times of a third of the height to get to this line and then back off. So that suggests that here we're doing 1 times height divided by 3 minus height, and then we can do a similar thing except 2. And we'll just go ahead and guess that the next one is going to be third. That's a little silly because that is actually just height, but to keep the pattern regular, I'm gonna leave it like that for a second. Okay. And now things are roughly in the right place. The horizontal centering is a little bit off. And I'm gonna leave that for just a second because I think at first we can simplify this code. And so the reason I left these like kind of gratuitously, like 3 times height divided by 3 is obviously just height, and 0 times width divided by 3 is obviously just the width, is obviously just 0. But I've actually on purpose made all of these follow the same pattern. So I've basically created a bunch of duplicate code where the expression, the assignment expression in each of these branches is the same except for this one number. And so then I say, is there a way I can figure out what that number is using math rather than logic? So right now we're doing an if statement to logically branch if it's less than a third, if it's between 1/3 and 2/3, and if it's over 2/3. Sorry, here's the logic, right? But that another way of looking at that is to basically say, what column are we in, right? So like column, I mean, actually I can even do, I'll do it in 2 steps. So I'm going to do the same thing as before. I'm going to copy this line of code, which now represents all 3 of those lines. And I'm going to just replace the one thing that differs with a variable named column. So then that means I have to declare a variable named column. And then inside this if statement, I just set it to the right value. Equals 1. And in this place, column equals 2. Okay, so now there's no duplication because these lines are all different. I mean, obviously the variable name is duplicated, but what they do is different. One sets it to 0, one sets it to 1, one sets it to 2, and then the XPOS is set. So just to check, still works as well as it did before, so that's good. And then now I'm at the point where I can say, well, so this follows a very regular pattern, like it's 0, 1, or 2. And this is when it's in the first third, or maybe we think of it as the 0th third. this is if it's in the second third, and this is if it's in the third third. Well, I can figure that out if I divided x by a third of the width, right? How many times does, if we think of the third of the width as our ruler, how many times does that go into x? Obviously, if x is less than a third of the width, then it will be less than 1. And if we rounded that down with the floor function, it would be 0. And so that works for the 0th case. And then if x was a little bigger than a third of the width, but not as big as 2/3, then it would be 1 point something. And if we took the floor of that, that would be 1. So this case is handled. And then finally, if x is less than if x is over 2/3, and obviously less than 3/3, because it can't be bigger than 3/3, then the floor would be 2. So this actually computes directly the value that we were otherwise figuring out by logic here. So now I can delete all that code. Also, now that I only assign x in one place, I can get rid of this declaration up here and make this const. Also, I can make this const because I'm not actually changing column. And so you can probably imagine that we can do a very similar thing with these lines that differ only in the number 1, 2, or 3. So I'll go ahead and make that const, get rid of this variable declaration, and I'm going to make this row, and then I'm going to say, how do I figure out the row? Well, it's a little different, but it's the same basic logic. If it's in the first third, it's 1. If it's in the second third, it's 2. And if it's the third third, it's 3. So we could just do, we'll go with that. So it's obviously 0, 1, or 2, just like before, plus 1. So we say 1 plus math floor y divided by height divided by 3. And we don't need any of this. And it works the same as before. And now we're at a point where it's like, maybe I could figure out an easier way, or not an easier way, but I can, now I only have one thing to change to get that centered a little better. And I don't really know, I mean, we went down to the line, that's like row times height divided by 3, backed off a third of that, which is a little bit too much. And so maybe now we need to come down to here. So that's like add in, and this is kind of goofy, but height divided by 18. Yep, okay, cool. So that's basically centered, should work on any size screen. So that's, and then we could come back here and simplify this a little bit if we wanted, or I don't know. So, but now there's only one place to change. So, I think that actually, yeah, I basically cleaned up all the stuff I wanted to clean up. So you can see the way to work is, it is perfectly reasonable. Like we started with a bunch of duplicated code, and my first move was to like recognize that duplication and then factor it out. So take the bits that were almost the same but differed only by 1 or 2 values, excuse me, and replace those values with variables, and then use the logic to set the variables to the appropriate thing. Later on, I actually created, almost on purpose, duplicate code that differed only in, again, one value, so that I could extract the duplicate code, replace the value that differed with a variable, and then set the variable properly. And then the final step was to recognize when I can set a value, a variable using math rather than logic. And so whenever you have a chain of if-else's and you are assigning a numeric value in the different branches of that, and it follows a pattern, you should look at how do you, could you just compute that with a mathematical expression? Just because computers are good at math, and it's easier to read. It's a lot fewer lines of code. Probably the last thing I would do in this, if some of you have been using this a lot, some of you haven't, but if you remember back to Pig Latin, I introduced an operator it's called the ternary operator, but it's made up of a question mark and a colon, and it lets you use, it's kind of like an if statement except for an expression. So instead of this whole if logic, I would assign the, I guess it would duplicate the Boolean a little bit, but I kind of prefer this. So this expression says evaluates to x if the first part move mod 2 equals 0 is true, and to O otherwise. And then we can do a similar thing here. Move mod 2 equals 0, and then it's going to be red or blue. And it's a little bit duplicate because it does this expression twice, but it makes this all just set up a bunch of variables and then draw the text based on that and increment the move. So we've now dramatically reduced the lines of code and also the complexity of the code, because we don't have these complicated chains of if-else clauses and these complicated Boolean expressions that you have to parse to figure out what they're really doing, but you can sort of see the mathematical relationship. So the marker and the color depend on whose move it is. I might even switch these around, and then we figure out the row and the column, and then we figure out the x position and the y position from the row and the column, and that's that. Now, the next step for this code is obviously to keep track of where the pieces are on the board, so you can avoid things like this where it allowed me to play in two positions. And it might turn out that breaking these expressions out into a separate function might be handy, because these are also, well, I guess I'll let the student figure that out. But it'll be a lot easier to break them out because they're isolated now. So anyway, that was another episode of Refactoring Student Code. Hopefully for the student who wrote this, it was helpful, and hopefully for the rest of you, because this is not the only code that I've seen that looks like this, and it's a very reasonable way to start. You can enumerate all the possibilities, and you can write a bunch of code that uses logic, and then find the duplication, and then simplify it. It's totally it happens all the time, and so you just need to learn to look out for that duplication and realize the techniques you have available to remove it and simplify your code. All right, so hope you got something useful out of this, and until the next time, see ya.